We have already discussed about the chain rule and how to find out the derivative using the chain rule. And let me give you once again a little bit brief idea of chain rule. A chain rule we need to use. I mean, this is a rule which gives you a quick way to find out the derivative of a composite function, a kind of complex function. Here y is one my complex function, a kind of composite function which is actually engulfing another smaller function t. This y equals to actually t minus 1 over 2t it is, and t is itself another function which is actually under root x plus 1. So this y is a kind of bigger function. If you write properly, this y will be now something like this. X plus 1, this is actually under root minus 1, and 2 times x plus 1. So the real y, if you look, it is like this, a kind of complex it looks. So here this y is actually a composite function, a function inside a function. This y is a function which is carrying a smaller function t. So that's why I used to say many times, this y is a bigger face. This y is a bigger face which is, inside the stomach of this bigger face you have this smaller face. All right, it's not bigger and almost equivalent there. Well, so see, so this is y is a bigger face. Inside the stomach of that bigger face you have the small face t, and now you need to find out the derivative of this bigger face. So to find out the derivative of such bigger functions, which is actually composing other smaller functions also, we have a trick actually, that is called chain rule. And this is something like this. If you have to find out the derivative of a complex or a composite function y with respect to x, and x is actually the main core thing of the function y. Smaller change in x, here if you see, smaller change in x can change the value of this whole function y. Then it is like, first you need to find out the derivative of the function y with respect to, y is a bigger function with respect to the smaller function, and a smaller function is here t. And then again you need to multiply this that quantity with the derivative of the quantity, means the derivative of the smaller function with respect to the main constituent of that function, which is x. Here if you see, the main constituent of the second function t is x, right? And we need to now differentiate this whole function with respect to that main constituent. Then it is like this. This is the rule. So simply you can say something like this also, like the derivative of the y with respect to x is actually something like a derivative of the bigger face times derivative of the smaller face. You need to multiply both of them and you will get the value. That's it. So now see here the main requirement is dy by dt and dt by dx. Alright, so let's find out derivative of this y with respect to t first. So here my given quantity y is t minus 1 divided by 2t, and another t I have root x plus 1. And let's talk about this first, dy by dt. So my dy by dt, well, I just wanna ask you a question. Guess which rule we need to use to find out this kinds of thing quickly. We have other method also, but if you want to find out quickly the derivative of these things, then which method we used to use? Yes, we use quotient rule in these cases. This will use this will work as a function u, and this will work as a function v, or you can say this will be your first function and this will be your second function. They will behave like them. And you know like if you have to find out the derivative of such a function which is like a ratio of two functions, u over v, u is one function here and v is another function, right? If you have to find out with respect to x, then it's simply v times derivative of the first function minus u times derivative of the second function, and then whole divided by square of the second function. Or simply you can say v du over dx times u dv over dx whole divided by v square. So the same thing I need to use here now, right? So now my first v I need to write, right? I need to write first v. So my v is actually 2t. So 2t times, I need to write now derivative of the first function du over dx. So derivative of this t minus 1 I need to do. Alright, so derivative of t minus 1 with respect to t. I finished this whole part. Now I need to write this first function, that is t minus 1, so times t minus 1, it is minus here, times now dv over dx, I means derivative of this second function v. So derivative of the second function 2t, it is not 2x, it is 2t, right, with respect to t, and then whole divided by, it's not straight, whole divided by square of this v, square of the second function. Here you can see square of the second function, that is 4t square, right? So now you can write dy over dt is equal with, see, it is 2t, and derivative of t equals to 1, and derivative of this 1 equals to 0, so it will be simply 2t minus, now this is t minus 1 times, this is 2t, so 2 is a coefficient, it will come outside, and derivative of this t with respect to t is 1, so there is no necessity to write 1, and then whole divided by 4t square, 4t square. Let me go a little bit down. So here dy by dt is going to be now 2t minus this 2 will multiply this t, you will get minus 2t, and this 2 will multiply this minus 1, since there is minus 1 more, so minus minus plus it will be, so plus 2, and then whole divided by 4t square. Hey, we got here something to cancel, minus 2t plus 2t and minus 2t will cancel out, and this 2 times 1 and 2 times 2, so finally you got your dy over dt as 1 over 2t square. Alright, now similarly let's find out this dt over dx here. So your dt over dx, you can write same quantity, something like this also, x plus 1 to the power half. So let's find out derivative of this function with respect to x. So now let's use the power rule, so it will be 1 by 2 times whatever the base you have, whose power will be now reduced by 1, so x plus 1 to the power 1 by 2 minus 1, and you'll get 1 by 2 x plus 1 to the power minus half, so that can be written as 1 by 2 x plus 1 inside the root, right? So your dt over dx, I hope you understand, this is minus half, when it will go, it will be in the bottom, it will be x to the power half, and x to the power half is actually inside the root, so whatever were our basic requirements, we write that, we find it out, that was dy over dt and dt over dx. So nobody can now stop us from finding out the derivative of our function dy over dx, right? So now our derivative of the function y with respect to x is simply, as the formula is saying, dy over dt times dt over dx. So in the place of dy over dt, I can now simply write this thing, so see here, dy over dt, I'm writing in this place, I'm going to write 1 over 2t square, now times the turn of this part, and here we have already find out, which is 1 over 2 x plus 1, this is inside the root. Now one more thing, we know that this t, t, why it is disturbing, that t is inside the root x plus 1, so let's put the value. So 1 by 2 x plus 1, it is inside the root, and whose square it is, and again 1 by 2 x plus 1, it is inside the root. So your dy over dx is now soon going to be this 2 times 2, I can write directly 1 by 4, right? And this is square, so simply you can say something like this, root x plus 1 combinedly cube, because here is 2 and here is 1, nothing, then there is power 1, so I'm writing directly, and this is your derivative, right? Here we are finished, we are done. Like this, we need to find out the derivative of the function, and here we use many rules, now you're gradually you're getting a complex formula. First here, here we discuss about the chain rule, and while finding out the derivative using the chain rule, we had to use a, fortunately, we need to remember this thing also, that is called quotient rule. We use quotient rule. And definitely during the quotient solving quotient rule, we use power rule also here, sum rule also, so here we did not use product rule, but sometime you may have to use any rules, so gradually you'll be getting more and more complex form, and you should be able to solve that problems. I hope you understand this problem, and we'll be trying to solve even more complex problem, which will give you more idea. All right, so we'll be meeting in the next video. Bye bye.